Hello everyone, good morning. Today we are going to cover the day 2 session of the Snowflake. In this, we'll be seeing the overview architecture of the Snowflake. So the Snowflake architecture explained, it is a modern cloud-based data warehouse. What is Snowflake? It is a cloud-based data warehouse as a service. We used to call it as a DWAAS, Data Warehouse as a Service. So it is going to provide us a service of the data warehouse. It is built for its scalability, performance, and simplicity. Scalability is nothing but whenever some computation is going on in the warehouse feels like the size of the warehouse currently provided is provisioned is very small, and it is not able to do the particular computation. So it has to upscale the warehouse size, and whenever the queries are less, it should be able to downscale the warehouse size. So for that only we are going for the scalability. Performance of the Snowflake is nothing but it's not only about the support of the warehouse. It does in all the three layers. The cloud service layer, which does a complete infrastructure management, and in storage layer, it stores whatever the kind of data we have used to get from the sources. And the simplicity is pay in use. So whatever the features of the Snowflake I'm going to use, I'm going to pay only for that. So works on the major clouds. It will be able to work in AWS, Azure Data Factory, and GCP, Google Cloud Platform. So this is fully managed, no servers to maintain. So we don't need any servers to maintain the Snowflake. Snowflake automatically does this whole infrastructure management. So we no need to maintain separate servers for this. This is about like what is Snowflake? Why Snowflake? Challenges with the traditional warehouses. In the traditional days, if you go and see the on-premises databases, the maintenance and storage cost will be very high. To overcome the traditional warehouse challenges, we are going for the cloud-based data warehouse called Snowflake. In the traditional warehouse, it's an expensive hardware and manual scaling will be done. So whenever the warehouse size is small and high, so the manually we have to upgrade the warehouse size and manually we have to downgrade the warehouse size. Limited concurrency means only few users will be able to handle the queries at a time as well as the warehouse at a time. Maintenance will be overhead. If you see that whole day, you see to that you have to maintain the traditional warehouses. What are the advantages of Snowflake is it automatically does the scaling and it always does the storage separation. So the warehouse size will be automatically upscale and downscale by the warehouse Snowflake. But in the traditional warehouse, we have to do it manually. The storage is separate for the Snowflake. But in the traditional warehouse, it is not separate. So it also includes a high storage cost. Snowflake go for pay as per use. Whatever the features of the Snowflake I'm going to use, I'm going to only pay for that. And also Snowflake allows multi-user access without slowdowns. Whenever I'm going to enable multiple users to access the Snowflake, there will be no downtime. Means like whatever the computation you are doing, whatever the processing the Snowflake is doing, that is not going to get disturbed whenever I'm going to provision multiple users to access the Snowflake. This is what the challenges with the traditional warehouse and the advantage of the Snowflake. Coming to the Snowflake data cloud architecture, the first one is workload, streaming analytics, business intelligence, data science, machine learning, data applications. The first level is what are the applications of Snowflake we are going to use. In the second layer, whatever the connectivity we are going to use to connect to the Snowflake. The third is client interface, that is Scala, Java, Python, SQL. The fourth layer is workload processing. How many warehouses you are going to get this workload done? And the fifth stage is data ocean. You are going to get the data from the different sources. It can be the structured data, unstructured data, and semi-structured data. And basically, the Snowflake will be supported by AWS, Azure, and GCP. This is data cloud architecture. The first layer is different types of the applications of the Snowflake. The second layer is how we are going to connect to the Snowflake. The third one is what are the client interfaces. The fourth one is what are the workload processing, multi-cluster warehouse going to support this operation. multi-cluster warehouse. To do this computation, the fifth one is different type of the source data we are going to get from the different sources. The sixth one is going to support all the three cloud architecture, that is AWS, Azure, and Google Cloud Platform. Now coming to the core architecture layer, Snowflake has the three main layers: database storage layer, compute layer, cloud service layer. Database storage means it stores structured and unstructured and semi-structured data. So compute layer means it performs all the computations and processing, which is taken care by the virtual warehouses. What is cloud service layer means it manages the metadata, security, and optimization. So it is going to manage what is metadata. For example, I'm going to bring some files from the AWS S3 bucket to Snowflake. So in that, what is the file name? When the last file is getting stored in the AWS S3 bucket. So those are the details of the file information, which we won't be getting from the source table. So those metadata has to be managed in the cloud, will be managed by the cloud service layer. And security means whomever the users getting login into the system, in the session, how long the user were active and how long the user were inactive, and how to do the query optimization. All this will be taken care by the cloud service layer. Visual idea is three-layer diagram stacked vertically. The compute layer and the storage layer are independent of each other. If you are going to store more amount of data, the computation can be less. If you are going to compute large amount of data, do the computation on large amount of data, you may be in a position to store very less amount of data. That is why compute layer and storage layer are independent of each other, and the cloud service layer does the whole infrastructure management for the Snowflake. What is database storage layer? Data stored in the compressed, optimized columnar format. So it follows the table rows and columns. Columnar format. Compressed means the file size, whatever the source records you are going to reserve, everything will be compressed and then only stored in the database storage layer. It supports JSON, Parquet, and Avro, the semi-structured data. The storage is independent of compute. It can scale separately. Sometimes you may be in a position to store large amount of data. You'll be doing very less computation and vice versa. Data automatically encrypted and replicated across the cloud zones. So once the data is compressed and optimized and it is completely processed, it can be encrypted and you can replicate the data in the different Snowflake cloud zones so that the different Snowflake accounts can access the data. Compute layer. It is independent compute clusters that perform the queries. Independent compute clusters performs the queries. The multiple virtual warehouse can work on the same data. So for example, I have a billions of data. So I cannot expect one single warehouse to do the entire computation of this billions of data. So I can expect more than one warehouse giving their contribution to work on this same billion amount of data. Enables concurrency. It allows the many users to access this data. Concurrency, no conflict. So multiple users can access the data and they can get the process done. So when the multiple users are accessing the data and they are getting done with the processing of the data, single user won't be getting interfered with the another user. So no conflicts between the users. The scale compute up and down without affecting the others. For example, I'm handling a billions of data. For initially, I have the extra small warehouse. Later, I feel that the Snowflake has to upgrade this extra small warehouse into small warehouse or larger warehouse. So when I do this in this worksheet or in this session, the other session of the Snowflake or other worksheet of the sessions won't get disturbed. So that only for this computation, the subscaling of the warehouse will be taken care without interfering the other process. This is what the compute layer. Cloud service layer. It coordinates all system activity. First, authentication and access control. Metadata and query optimization, monitoring and transaction. Authentication is in this session, how many users have logged in, whomever access the Snowflake data, and how to give their access control. What are the roles and privileges has been provided for this user so that they can access only this part of the Snowflake objects. They cannot access all the objects of the Snowflake. Metadata and query optimization. I'm going to load a file from the S3 bucket to Snowflake. I want to know what is the file name and on which date the file has been uploaded. So with this, excuse me. So it coordinates all the system activity, that is cloud service layer, metadata and query optimization. Of course, I explained this using this. Whatever the file regarding information, what is the file name, file size, those things will be stored as a metadata in the Snowflake table, because these file informations we won't be getting from the source table. And what is monitoring and transactions? So monitoring of the Snowflake and what are the transactions has been done, those things also will be covered in the cloud service layer. It acts as a brain for the Snowflake analogy, like a traffic controller managing compute and the storage communication. So benefits of the Snowflake. So separation of the storage and compute. It handles structured and semi-structured data. Automatic scaling of the workload spikes. Zero management, fully cloud native. So first storage and compute layer are separate. It is going to handle both the semi-structured and semi-structured data. Automatic scaling means upscaling of the warehouse and downscaling of the warehouse. It is fully cloud native, so infrastructure management will be taken care by Snowflake itself. And high availability and data sharing made easy. So as it is a cloud-based data warehouse, it is highly available in the market every time. So anytime the people wants to do the accessing of the data, they can do it immediately, and it is data sharing. Data sharing, it's made easy so that anyone can access the data and do the process. So benefits of Snowflake are data quality monitoring. They have to maintain the quality of the data. The workload separation and concurrency, multiple user access and multiple queries access. Snowflake administration, infrastructure management, which is done by the cloud service layer. Data exchange is nothing but the data sharing. Automatic query optimization, using the caching concept, whatever the queries recently the Snowflake has run, it should be able to process the same query again and again, so that it won't be able to access the table every time. Rather, it will be taking the data from the recent queries. Multi-cloud support, AWS, Azure Data Factory, and GCP. Snowflake Marketplace. In the Snowflake Marketplace, we will be in a position to upload the real-time data, so that the people will be able to understand the marketplace. They will see the real-time data, whatever the source data or the process data we are going to store in the Snowflake data warehouse. Data ingestion improvement. Very first time, whenever we are going to get the data from the source, so we are going to ingest the data into the Snowflake using the tools like Phytron or Matillion tool. So these are the benefits of Snowflake. You are going to improve the ingestion process, data quality will be maintained, separation of the concurrent users and concurrent queries, infrastructure management, data sharing, query optimization, multi-cloud support, and real-time data analyzing. So these are the benefits of the Snowflake. So overall, Snowflake is a cloud native elastic data warehouse. It has got three layers called storage, compute, and cloud service, designed for performance, concurrency, and simplicity, and it is most ideal for modern analytics and big data solution. I hope everyone is clear with this session. If you have any queries, or if you have any, if you are in a need to upgrade extra content of this sessions, please drop your query in the below link. Thank you all.